Okay, 2.1, a preview of calculus. Make a share screen. Whiteboard. Preview of calculus. Okay, so we have the function f of x equal to negative 2x minus 3. G of x equal to 1/2 x plus 1. And h of x equal to 2. We know this. The first one looks like that, okay? And second one, straight line like this, okay? And third one, like this, right? Or the straight line. We call this is a linear function, linear equation, okay? We are using function notation, so it's a linear function, right? Then they telling us the slope, right? Which one is the slope in the first one?
-2.
-2. So this is a slope. And second one? 1/2. And then third one?
0.
Oh, excellent. Slope is 0. Right? Very good. All right. So we say that, okay, slope is indicate the rate of change of the function. So basically, slope of linear function indicates the rate of change of the function, okay? Then what if we have like this? What if we have like that? What if we have like this? Okay, how do you find the slope? So let me erase this one. And then so hold on 1 second. We give you co-host. Okay, so please microphone. Okay, share screen one more time. All right, so look, we learned this one in pre-calculus. So we have a curve, a function, okay? Now we want to know about the slope, right? Then let's say that we have 2 points here, okay? We knew from algebra, if there is a straight line, we can find the slope, right? So why don't we make a straight line? Okay, so we're gonna make a straight line, straight line to find the slope. Okay, let's see. Let's say that this is A, this is X. I just follow your book notation. Okay, then this point is order pair. So A for the first one, and second one is the Y value, which is f of A. Okay, then second one is A, the second order pair, which is the first one, X, and then the Y value, which is f of X. Okay, we called this line is secant line. It's not like a trigonometry secant. Okay. Let's see. Where I put it? This one. So this is secant line. Okay. Then from previous, like a pre-calculus, we do this notation. Remember? And then they said a secant, right? So this means slope of secant line. Okay. Then from algebra, what do you have? The formula for slope. Hey! Wake up!
Rise over run.
Rise over run. Excellent. So that is change in y in change in x. Okay. Same as here. Change in y, change in x. That is y2 minus y1 over x2 minus x1. Okay. Since in this case they're using function notation, look, y2, this is x1, y1, right? x2, y2, it's the same thing, okay? So that is y2, which is f of x, minus y1, which is f of a, over x2, which is x, and minus x of 1, which is a, okay? So we call this is slope of a secant line, okay? But basically same thing with the algebra, right? Okay, they make a little bit advanced notation, function notation, okay? So this is the definition about slope of a secant line. Then look, we have 2 points, okay? Then one point is getting close to other point, okay? So let me move. This point, we want to move here. Then draw the line there. Okay, this point move here and draw the line. Okay, this point move here, draw the line. Okay, this point move here, draw the line. This point move here, draw the line. This point move here, draw the line. Can you see that? The 2 points getting close each other. Okay. So we called we call this is tangent line. Okay. So we said that this will be later limit. Let me write down this one. As x approaches a, that means x is getting close, or 2 points is getting close to each other. Okay, the secant line becomes tangent line. Approaches the tangent line. Okay. All right, so let us do these. Estimate the slope of the tangent line. Okay. Look, they say that parenthesis is the rate of change. To f of x equal to x squared at x equal to 1 by finding slopes of secant lines through 1, 1, and each of the following points on the graph. Okay, so first one, 2, 4. So we're gonna find the slope of secant line. Okay. So change in y, change in x, right? So that is, let us make just ax a little bit confused. So let us make x2 minus x sub 1 over x2 minus x1. Okay, how about that? So in this case, let me draw. There's no space. Let me draw this one. Approximately. I just follow 1, 1 here and 2, 4. So 1, 1, 2, 4, and then secant. All right, so f over x2. So let's make x sub 1, y sub 1, this one. This is x sub 2, y sub 2, okay? Then f of x2, which is f of 2. F of 1, 2 minus 1. Okay. F of 2, what do you get?
4.
4. Okay. We plug in when x equal to 2, so 2 squared, which is 4. F of 1, what do you get?
2.
2?
I think it's 1.
1.
It's 1, right? It's 1 because f of 1, we plug in 1 into the function, 1 squared, which is 1. Okay. So it's 1 over 2 minus 1. So 4 minus 1, 2 minus 1, 3 over 1, which is 3, right? Okay, let me erase top. Okay, we have a fraction. Secant. So 3 over 2, 9 over 4. Okay, in this case, this is the x sub 2, y sub 2, right? So we do slope of the secant line, which is 3 over 2. 1 over 3 over 2 minus 1. So f of 3 over 2, what do you get?
9 over 4.
Good. F of 1 we did earlier, which is 1. And that, okay. Denominator, which is 2, it's 1/2, right? Numerator, we have 5 over 4. So what do you get?
1.
That's your favorite number? You keep the 1? Is it 1?
10 over 4. Oh,
So we get 5 over 2, right? It's okay?
Yes.
All right.
wouldn't it be 10 over 4?
10 over 4,
So
sorry.
5 times 2.
Dang.
Oh, 5 over 2. Sorry, I messed up.
It's
My bad.
okay.
I see what happened now. It's 10 over 4, which is 5 over 2.
Understandable, right? We misthink sometimes. Okay, that is good. So let's see. Okay, so we learn from the algebra. We talk about the velocity, right? It's also rate of change. So we have two types of velocity. One is average, one is instantaneous velocity, right? Okay, let me talk about average velocity. Let me write down. Definition. Let S of t be the position of an object moving. This is a time interval. It's not for, it's or. Or TA if T is less than A. Okay, we denote V, that's not V. V, okay. We denote average velocity like this way. Okay, then this is average velocity. Then this is the same as the slope, which is rate of change. Okay, look, S of t is bigger one, S of a, right? Over t minus a. Okay. Now, instantaneous velocity, we talk about limit later on. Instant. Let me write down. Position function. Spell. It's 10, NE, velocity. By the way, my car is a Veloster. Do you know that card? Car, not card. Car, Veloster.
Hopefully it's fast with a name like that.
The average. Intervals of the form. Letter English. Okay, so this is basically same as earlier. The average velocity is the same as slope of secant line, okay? And instantaneous velocity is the same as slope of tangent line, okay? 2 points is getting closer each other, okay? And then the instantaneous velocity will be limit later on. So they said provided such a value exists. So we said the limit exists, okay? All right, so we're gonna have 2 problems, then we are done for today. So your homework most likely ask you about the slope of secant line and also the instantaneous velocity, right? Okay, so instantaneous velocity, I'm gonna show you how to find from now on, okay? Then you can do most of the homework, all right? Let me erase. A rock is dropped from a height of 64 feet. T is between 0 to 2. It's given by position function. S of t, which is negative 16t squared plus 64. Find the average velocity of the rock over each of the given time intervals. Okay, use this information to guess the instantaneous velocity of the rock at time t equal to 0.5, okay? So if your homework is like that, okay, without any example, okay, then close the point we're gonna find. So t equal to close the point for 0.5, which is 0.49. What do you think? Yes? Yes or no?
Well, how close should we get? Like, should we have more decimal places, or is that kind of considered good?
Yeah, it's a 0.49. Is close enough?
I'm not sure, possibly.
Because they said a guess.
Yeah.
All right. Okay. And then your homework said that, oh, your answer must be within 10% of answer. Okay, so 10% of your answer is inside the 10%, then they're gonna make you correct decision. That is correct. Okay, and then t equal to 0.51 is also close to the 0.5. What do you think?
Yes.
Yes, okay. So your homework, like ask you about the instantaneous velocity, do that like this, okay? Clear? All right, now, in this case, they give us the interval, right? Which is the same as we guess. Okay, that is, let me use the average velocity, right? So average velocity, that is S over t, so 0.5. I need your help. Can you please find out what's S over 0.5 and S of 0.49? Okay, so basically we plug in, substitute there, right? So t,
Is it 0.5 or 0.51?
0.5 for the first one.
Okay, so you do it twice? You do it for 0.5?
Uh-huh.
Okay, cool.
I think S of 0.5 is 60.
So you said 60?
Yeah.
Thank you. What did I say? Don't try to be you are cute. Only cute person is me. You get scared? S of 0.49. What do you get? It's okay. Answer.
I got 60.1584.
68. Sorry. Thank you. 68. And then what else?
Okay. I got 60.1584.
60.158.
Yeah.
Okay. And then can you please calculate everything? And please calculate this one as well. So what do you get? The top first. The first one, what do you have?
I got negative 15.8.
Okay. How about this one? Second one? S of 0.51. What do you get?
I got negative 16.16.
So,
Sorry, I thought I was drawing on my whiteboard.
oh yeah, you good. But we don't have time right now. Can you erase this one? I cannot erase because you wrote down, so. Can you erase this one? Good, it's good. Yeesh. Thank you. So let me use her answer, okay, since we don't have time. So this will be, she said that, it's okay, thank you. So negative 16.16, right? Does anyone has hard copy of textbook? So textbook has made a mistake. So it's supposed to be negative 16.16, not the negative 16.016. Okay, so test your textbook. If you have a hard copy, they made a mistake there. Now, how do we find instantaneous velocity? Okay, so let us denote like that. So this will be negative 15.8 plus two number, we add them. And then since we add the two numbers, the average of two numbers divided by 2, then what do you get?
Negative 15.98.
So this will be feet per second. Okay. So this will be answer. So in your homework, if they ask you about the instantaneous velocity, you guess the number like that, like this, okay? And then do like AB like that, okay? Then add two numbers and divide by 2. Then that is the instantaneous velocity, all right?